Hello everybody, welcome back to another video. This is the second video in our first unit on EDA, and in this video we're just going to be reviewing a couple of concepts from Python. For some of you these concepts might be very fresh in mind from Math 9, otherwise this will serve as a really good reminder. So I have a couple of sample exercises here, and the first one asks us to make a length 1000 array of random real numbers between 0 and 10 using NumPy. So just as a refresher, well, what is NumPy? It's one of the most important libraries for Python, and functionally it's very similar to MATLAB. So if you're more comfortable with MATLAB, NumPy will feel very familiar. And the way that we use NumPy is, well, first we have to import it. It doesn't come with base Python. So very first thing I'm going to do is say import NumPy and then the word as. And you can see here it's already auto-completing it for me as NP. Now this NP is a standard abbreviation. We should always use it. In theory, you could put anything that you wanted here. It doesn't matter, but NP is the standard convention, and that's one that I expect us to follow. So first, let me import NumPy as NP. And now, okay, so we want to deal with random real numbers. And the way we do that is by instantiating what's called a random number generator object. So this is one example of object-oriented programming in Python, where instead of using functions that make random numbers, first we instantiate a random number generator object, and then we use methods on that object. So the way this works is I say Rng equals np.random.default_Rng open close parentheses. So on the left here, this Rng, which stands for random number generator, this is the variable name. Again, it could be anything that we want, but Rng is standard, so let's use it. And everything here on the right needs to be exactly as written. So if I run this, no issue, so that's looking good. And first thing I'm going to show you is one method on this Rng object. So how do I get random real numbers? Before I make a length 1000 array, let's do something smaller so we can kind of look at it. So I can say Rng dot random. If I call it like this, so no parameters, what this does is it returns a random real number between 0 and 1. Instead, if I do something like Rng dot random, and then I pass a number, let's say 5, what this does is it returns a length 5 NumPy array populated with random real numbers between 0 and 1. So here, random is one method on Rng. What if I wanted integers instead? Well, as you might guess, I can just use the word integers. So I have Rng.integers, and the syntax for this one is I tell it where do I want to start, where do I want to go, and what size should it be. Like usual, the left endpoint is included, the high point is excluded. So it's, if I say, let's do, I don't know, 0 to 20. Let's say size is equal to 3. So this is going to return a length 3 NumPy array of random integers between 0 and 20. So you can see here I got 0, 17, 12. I could do something like 20. And see here I get 19. And I could run this over and over again. So notice if I run this again, I'm going to get different numbers. And notice 20 is never going to show up because, again, we don't include this right endpoint. So 19 is included, 20 is not. So this is looking good so far, but it's not the question that we were supposed to answer. So it's saying make a length 1000 array of random real numbers between 0 and 10. So the random method, this is always going to return a real number between 0 and 1. And there's no parameter that allows me to adjust the interval. So what we do instead is, okay, so we're dealing with the interval 0 to 1. I instead want to go from 0 to 10. So the way I do that is I just multiply by 10. And then what that does is it takes the interval 0, 1 and it stretches it to be 0 to 10. So what I mean by that is I can say ARR equals Rng.random. I'll say 1000 because I want 1000 random reals. And now I'm just going to multiply by 10. So that's ARR, no errors. If we wanted to, remember this is an example of something called slicing. I could say ARR, give me the first 10 elements. And we can see here, so there's 0.355. I get 9, there's 8, 5, 4, and I'm just reading off the integer parts, but we can see these are the first 10 elements of ARR. And okay, this is looking good so far. This is exactly what we wanted to do. Maybe one other thing I want to show you before we try answering this next question is, so unlike MATLAB, base Python, so Python without importing any external libraries, has very few built-in functions, but there are two built-in functions that are quite useful. One is len for length, and what that does is take the length as you would expect. So for instance, I can do len of ARR, and this tells me 1000, and that's good because that's exactly what we wanted. And the other one that I want to show you is max, so this is going to tell me the maximum. So remember, these are random reals between 0 and 10, so let's see how close to 10 we get. And we can see here, we get 9.978, So okay, this is looking good. Keep these two in mind, because now we're going to answer, well, what proportion of the elements in this array are strictly greater than 7? So again, as a reminder of slicing, if I just want to look at, let's say, the first 10 elements, as we did before, here they are. We did that here, oops, and here as well. Instead, let's say I wanted to look at just like the first 5. So we can see here, this matches exactly the first 5 elements here. And what I'm going to show you now is something that works exactly the same in MATLAB, and it's worth getting comfortable with if you haven't seen this in a while. So for instance, if I do ARR, give me the first 10 elements, and I ask, where is this greater than 7? What this does is it returns a Boolean NumPy array where it returns false everywhere the corresponding element in ARR is not greater than 7, true everywhere else. So for instance, 0.3 blah 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 is not greater than 7, so that's false. 8.9 is greater than 7, so that's true. This is going to be false. This is going to be true, and so on. So definitely spend some time understanding this if it's unfamiliar. But now that we've seen kind of how to check at this Boolean array, all we have to do now is remember how false and true are treated, right? So another reminder, if I do something like true plus true, remember true is treated like 1. So if I add them together, I get 2. Versus if I try something like true plus false, remember false is interpreted as 0, so what should this return? This gives us just 1. So if I want to count how many elements are greater than 7, well, I just count how many trues there are, right? So 1, 2, 3, and then I can imagine false is just adding 0 a bunch of times. So for instance, if I do something like sum, ARR, let's take first 10 elements and ask, are these greater than 7? Notice here I got 3. So now all we're going to do is extend this same idea to the entire array. And to get the proportion, well, we're just going to divide by how many elements there are. So for instance, let's do ARR greater than 7. And let's take the sum. So how many elements are greater than 7? And now we divide by how many elements there were to start with. So it's 1000, but to make our code more robust, so say I changed the length of ARR, maybe I made ARR smaller or larger. If I pass the variable here, I wouldn't have to change it. So let's see here. And it's saying here about 30% of our elements are greater than 7. And this makes sense, right? Because if we're imagining a number line going from 0 to 10, we're thinking how many elements live in the interval 7 to 10, or kind of what's the length of that interval? Well, that's 30% of the interval. So makes sense, our answer looks good. And the last question I'm going to answer here is, well, let's convert the array to a list and answer the same question. So the same question about proportions. So let's remind ourselves, how do I cast to a list? Well, I type the word list, and then I say take ARR. So pass ARR as the argument. I'm going to convert it to a list. I'm going to say my list equals list of ARR. Again, this is a reminder of the importance of giving your variable names somewhat random names, right? Notice if I remove the word my, this replaces list with whatever this is here. So list is a built-in keyword to Python. I do not want to change it. So my list, notice it doesn't get highlighted. I'm not overwriting anything that's already defined. So now my list is the list version of array. And I'm just going to remind you of a few things that are unique to lists. So let's say like list comprehension. So What I mean by that is, what if we did something like x for x in my list, so saying go through every element in my list and keep it if x is greater than 7. And let's see, it's not happy with something. Oh, do you see here? I meant to type greater than, but there was just a space. So this is kind of all of the elements that are greater than 7. So okay, looking good. Let me call this, let's say, count. And if I take the length of this list, that's going to tell me how many elements are strictly greater than 7. And then now, same idea as before, I'm going to take count divided by the length of ARR, and that should give me the proportion. So I get 0.308, exactly what I got before. So, all right, quick review of some essential Python concepts, kind of quick intro to NumPy generating random numbers. Thank you for watching. I'll see you in the next video.